Okay, these are our notes for lesson 1, 2, linear functions and models. This is stuff you should know from Algebra 1, but we're going to cover a couple things today. And anyway, hopefully you'll remember all of this. Okay, you might be familiar with this form, y equals mx plus b. When we're using function notation, we call y f of x. But it's the same y equals mx plus b that you remember from Algebra 1. The m stands for the slope, and the b stands for the y-intercept. Any point that's on the line, if you plug the x in along this m and b, it will give you the y of the point. Okay, so we need to graph this linear function. I hope to teach you now kind of an easy way to graph. And basically, what I don't want you to do, it's okay if you do, but it just takes so much time, is if you do this, right? 1, 2, 3, 4. All that takes way too much time, and I don't want us to waste time drawing lines like that. So what I'm going to recommend is that, well, in this case, we know that our y-intercept is 7. Okay, so let's go ahead and mark that. We'll start. This is the point 0, 7. Okay, you'll notice that I'm not going to bother drawing 6 or 7. That's here. I'm not going to draw 2 marks right here. I'm just gonna eyeball it. Okay, our slope is -3, and so that means we're going to go down 3 and over 1. Okay, so notice that our height is currently 7. So if we go down 3, that's going to be to about 4. But I'm just trying to show you what I'm doing here. And then we're going to go over 1. Put a mark right here, and since we went down 3, the new height is 4. Since we got 1, the new x value is 1. And with these 2 points, we pretty much got the entire one. That's all that's required. Okay, let's try something slightly more complicated. A slope that's not a perfect whole number. Again, I'm going to not get too caught up in drawing tick marks. This time I do the negative y-axis because my y-intercept is negative. So the first thing we're going to do is mark here. 0 to the right and down 1, so that's 0, -1. And we're going to use the slope now to get to the next part. The slope is 2/3. What I want you to imagine happening is this is rise over run. So it's going to rise 2, it's going to run 3. Okay, so if you rise 2, we're currently at -1, so if you rise 2, that's going to take 0 and then the 1. And then we're going to run 3. So that's going to go 1, 2, 3. Okay, and at this point, we went up 2, so that takes up to 1. And the run takes us from 0 to 3. And then you connect the dots and you have found the equation of the graph of the line. All right, and one more. Okay, this one looks confusing, but it's actually the easiest one that we're going to do. Draw our y-axis. Some of you might be looking for an x, and I suppose it's there. So this is negative 0x. Or if you want to write the x first, it's 0x minus 3. Now, they didn't bother writing the 0x because 0 times x is nothing. So they didn't see fit. So, but once you do that, you can see that we do have a y-intercept. It's -3. So I'm going to go over here. I'm going to call this point 0, -3. And the slope is 0. So if you think about it in terms of rise and run, you're going to rise 0. And you're going to run as far as you want. It doesn't matter. What you see here, this is a horizontal line. In terms of a function, this is called a constant function because whatever z value you input, the output is always -3. So this is a constant function. It's constantly -3. Okay. Oh no, word problems. Don't be afraid. This one's actually quite easy. The first thing I'm zoning in on is the, I can't choose my highlighter because I don't want my cover. Anyway, the first thing I'm going to notice is this function right here. This is a cost function. Okay, mx plus b. You'll notice it's linear. And the way this works for a business is that, in this case, we're talking about bicycles. Every day they show up, they gotta pay a certain amount of money. This is a fixed cost, okay? And so that means that, they've got rent to pay, they're gonna have to pay for the lights, they're gonna have to pay for their workers, and that much is gonna be constant. Okay? So this isn't a line set. Even if they don't make any bicycles, they're going to pay that much money. Now, this part is the variable cost, okay? Because as the number of bicycles, X, as the number of bicycles goes up, they're gonna spend more money on the variable cost. Okay, so it says write a linear function that expresses the cost of manufacturing X bicycles in a day. We're just going to use this function right here that they described for us, and we're going to plug in the numbers they give us. So the cost that they spend manufacturing bicycles is going to be n. So every bicycle that they build, as X increases 1, right? As X goes to the right one, we're making one more bicycle. They want to know, how does that affect the cost? How much is the cost going to go up? Okay? And they say it costs $110 to manufacture a bicycle. Okay? This is our slope. The rise is $110, the run is 1 bicycle. So $110 times the number of bicycles, plus, and B, our y-intercept is the fixed cost, which they tell you here is $1,500. That's what they're going to be spending, even if they don't make any bikes. Or if they make 1,000 bikes. The fixed costs are going to be the same. Graph the linear function. We'll do that on the next page. And this is what's the cost of manufacturing 31 bicycles in a day. Well, 31, this is our input value, right? It's independent variable. They're saying, what's the cost? Well, the cost is the dependent variable. It depends on how many bicycles they make. And we know that's 31. So all we have to do is plug this into a function. The cost, it depends on how many bicycles we make. We're going to make 31. I don't know if I'm going to use this in my head, but it's going to be 110 times 31 plus 1,500. And you can just plug that in the calculator. Then you can do it in your head. 31 times 100 is 3,100. 31 by 10 is 310. So that's 3,410 plus 1,500. So that's 4,910. Hopefully they can sell all 31 of those bicycles and make some money. So we're going to graph this linear function on the next page. 110x plus 1,500. Okay, we're going to graph the function. 110x plus 1,500. Okay, this is going to work exactly like the problems on the other page. Notice that I've only drawn the first quadrant because we can't have negative bicycles and we can't have a negative cost. I'm going to start here. This is going to be my y-intercept. If I make 0 bikes, I'm still going to spend $1,500. And then rise over run. I'm not going to be that particular about it. I'm going to rise $110 and I'm going to go over 1 bicycle. Okay, so if you rise $110, your costs are now $1,610 and you made 1 bicycle. But here's the line we've graphed. Okay, the other thing I want to discuss today are scatter plots and lines of best fit. We have a group of data here. So this is all at the room temperature of 70 degrees. And apparently, the humidity in the room is going to affect how warm or cold it feels to human beings. So the first thing I just want to do is make a scatter plot. And essentially how that works, I'm going to do it in the calculator. You can do it on paper. But in the calculator, I might need to slide this over. Okay, if I want to draw a scatter plot, the calculator needs to know my data. Okay, at this point, the calculator hasn't read this, it can't read. But what we have to do is tell the calculator the data. So to do that, I'm going to add it. Now, I've entered most of the data already, just to save ourselves some time. So from 0 to 80, and to enter more, you just type it in, and then I'm entering the first value, the input variables, in the first column, and the output variables are going to go in the second column, 75 and 76. Okay. Now the computer knows the data, and I want to look at this data. I'm going to need to do a scatter plot, so I need to put second y equals it. It's a scatter plot. It sounds like a scatter plot. So you can pick any of these. You'll notice that they're all off initially. I'm going to turn the first one on. I'm going to enter. Turn it on. Okay, and all we want to go with list 1 and list 2 because that's where we put our data. You can choose any one of these marks that you like. And then if we hit the graph button, we're actually not going to see any of this. Now, the reason we're not is because our window is off. We're looking between -10 and 10, -10 and 10. And you notice that all of our y values are outside of that range from -10 to 10. So what we're going to do instead is we're going to pick the window. And the x values, again, they are represented by these input variables, which range from 0 to 100. So I'm going to go from -10 to 110. A little bit lower than the lowest and a little bit higher than the highest. We'll put a mark every 10. Okay, our y values range, let's see, the lowest is 64 and the highest is 76. So let's go from 60 to 80. I'll let this to mark be 1 degree apart. And then we look, and there's our data. Okay, so that's a scatter plot. Now, what we like about scatter plots is that they help us visualize data. And hopefully you can see by looking at this, that's pretty linear. You can almost draw a straight line through all of those dots. And we're going to talk about how to do that. Okay. So, first of all, when you talk about something that's called correlation, you should have seen this in Math 1. Basically, when you look at a scatter plot, and this is what we saw on the previous, on the calculator, I can bring it right back up. The data that we looked at, it looks like it's almost in a straight line. And so anytime you see the data line up where it appears to almost be in a straight line, we say that it has linear correlation. Okay? And if that line is moving up from left to right, it's positive. If the line is moving down from the left to right, but it's still linear, it's negative linear correlation. Okay? If it looks completely random, we say there's no correlation at all. And then in some situations, and this is just one example, you might have data, like this might be quadratic data, right? And so scatter plots are very helpful because they help us to see immediately what might not be evident if you just look at the graph or you just look at a table or a function. So we like scatter plots for that reason. Okay. I think quickly I can show you how to, if I didn't have a scatter plot on my calculator, I could draw it myself, and then if you want to come up with an equation, you can just pick any two of the points, and ideally you would look at them in a scatter plot, and you make the line based on those 2 points. First you find the slope. I'm going to take the second y, the first y, and the second x, count the first x, so 70% and 40%. So that's a slope of 5 degrees over a tangent humidity of 40%. That's a slope of 1/8. And I know we just do y equals mx plus b. So the appearance picture is y equals the slope is 1/8 times x plus, well, the y-intercept is the y value where x equals 0. So we can just throw in 64. Now this is quick and lazy, but that's a pretty decent prediction. All right. I actually want to get a better prediction from the calculator, and I'm going to follow these steps. We've actually already done the first 3. We're going to pick up with step number 4. To run a regression, that is to say, what's the best line? Stat. So we did stat edit last time. Now we're going to stat count. So hit the right button and linreg. That stands for linear as in line, and reg as in regression. We'll go there. And then enter. Okay. And it's going to show up for us. As you can see here, R is really close to 1, so that's a really good fit. If your R doesn't show up, then you can follow these directions right here. And then the last step, if you wanted to graph this to make sure it's a good fit, go right back to y equals. You hit this button, forms or variables. And we've been using the stat button, so we're going to go down to statistics. And then finally, we want regression equation. You see here EQ for equation, and the reference one is regression equation. And it copies and pastes all that data for you. Then you can hit graph, and you can watch how well it fits. Okay, so that's how we do that. We haven't answered any questions. We haven't gotten the graph in here. But you can go to the MathVets website, which I've linked on our page, and you can find information.